Hi guys, do a little video here. It's in regards to kind of a small discussion that was done. I was involved in, but it has to do with the detector tube and how the diodes are connected. I want to show you the three most common ways that they are connected. There are various methods, but then I'll show you some schematics of examples of this. The first one is where we have our secondary of our second IF here, and we feed the signal in. We have a filter we talked about before that is our primary filter for the 455, but our signal comes in to the diode, one of the diodes, and we have a diode between the cathode and the plate that's going to ground, so our signal path will be in this direction, around, down to ground here, back. Okay, so when this diode is doing all the duty of detection and AVC. In this case, now sometimes they may have a resistor located also going to ground. This would be your load resistor. In other cases, to save money, they don't do that. They actually use the volume control, and one end will make either direct or snake its way to ground, and this becomes the load right here. And now if it is using the volume control for load, it's very vital, if you ever replace this volume control, that you get real as close as possible, if not the exact value, because it's very imperative. Because what the load does is it develops the negative voltage for the AVC, which is also the primary is the grid voltages to for your front end of your radio. If this is wrong size, then that voltage will be different, and the radio will not operate properly. What they do with the second diode in this case is they just take it and connect it to the cathode, which then is returned to ground. Now, in some circumstances, this connection, depending on how they're wanting to bias the triode section, they may use self-biasing by means of cathode resistor. In that case, this diode could still be connected here, but a lot of times they'll just go ahead and just run it to ground. It doesn't matter whether it goes directly to ground or to the cathode. There is no loop here. Primary reason is there's no way to bias the diode at all. It'd be like taking a modern day diode and just connecting it to itself. You got a modern day diode here, and it'll have a stripe on one end showing the cathode, and it'd be just like you taking that and connecting it, the two leads together. So nothing else there, so the diode cannot be biased. This is one method of connecting up the diode, and I will show some examples of that here in a little bit. Another method that can be used is we run the diode out, and we actually use it for the AVC. We may put a cap here, it'll be in the picofarad, or in some radios they chose to, instead of putting a cap there, they put a resistor. Either way, this thing will go down and come back and make a connection usually on this side. There may be a load resistor on it, may not be. That all depends on whether you're using a resistor here or a cap. If they use a cap, they generally will have some load resistor connected to it. They also may just use this as a load resistor or the volume control as a load resistor. This resistor here, various sizes. The older radios, they were 1 meg. Newer radios, they went to 2.2 meg. But this works in conjunction with that, with a 0.05 microfarad cap to build the RC filter for the audio, so you don't have any fluctuation in ABC in regards to fluctuations in your audio signal. Another means of connecting the diodes, connecting that second diode, get rid of all this, is actually just connected the two diodes together. Again, in all cases the cathode is either going directly to ground or through a cathode resistor. But another method is connect the diodes together. You get double, it's just like putting two diodes in parallel. It serves no actual purpose whether you connect the two together or not. The only thing is, when they are connected together, the diode in these tubes, just like a silicon diode, takes around 0.7 volts. In theory, generally usually around 0.6, 0.5 to forward bias. In other words, the voltage has got to get above that level or the diode don't conduct. Well, these, depending on the tube and stuff, takes a certain amount of voltage and to get them to conduct. It's called the bias voltage. If you connect two diodes together in parallel, the voltage will be basically the same, but the current is increased, needed to get the diodes to conduct, which puts a little more load on the IF can, and that requires a little changes in this IF can, the windings, to do this. Generally, most manufacturers will just use one diode, connect this to ground or to the cathode and then to ground, and just use one diode. Saves on circuits, parts in the circuit. But the older radios, they did use, a lot of times they did use the second diode as a basic ABC diode, where the first diode would be the detection diode. And so this would be connected through into the circuit and to help produce the AVC voltage. And again, you'll either have a capacitor here or a resistor here. Sometimes it basically is picking off the signal from here, so it may be just actually fully connected to this point here and picking up the rectified voltage coming off of here and further rectifying it. Those are the various methods of connecting the diodes. There were newer tubes that came out later that actually only had one diode in them. They were just, they could be a triode and one diode, or they could even be a pentode and one diode. But they, you know, in later years, in the 50s, they had determined that we don't need both diodes, and most manufacturers are doing something with this diode, either connecting it to the other diode directly or more generally connecting it to ground. to take it out of the circuit, and so why continue producing a tube that has both diodes in it? So they started producing tubes that had only one diode in them. So, some things to look at. I'm going to show you, let's see here if I can find what I'm looking for. Here's one schematic, and here's what really started the discussion with this schematic. Again, if you hook that second diode to the cathode, I mean, the cathode is going to go to ground at some point. It has to complete the circuit. But that second diode connected to cathode, it may appear like a loop, but there's no biasing voltage, and with no biasing voltage, you cannot, the diode's not going to conduct. Now, and that was really the subject of all this. This radio, and let me see if I can kind of zoom in on this. Because I want to zoom in and kind of, this particular radio, here's the second IF, and here's our diode detector. It's also the AVC. This diode is doing everything. It's your AVC and detector. Alright. Here's the cathode. Here's the other diode. It comes down and it is connected directly to the cathode. But if you actually follow this line, well, it goes to the phono jack, goes this cap, goes down over here and actually hooks to a shield on a cable that's going to the phono jack, resistor to another shield, and down, and I'm probably getting off camera here, and let me zoom out a little bit. Goes down to here, comes across, connects here, connects the cathode here of the tuning eye, and down to ground. So be very careful when you're looking at schematics like this that you don't start jumping to conclusions. Follow your grounds out. If you have to, mark them out, highlight them, or whatever. But you need to follow these lines. The cathode and that diode right here, these two guys, yeah, I got you all. This cathode and the diode are all going down and down to ground. Now some schematics will show the grounds right up close. In fact, on this one here, when you get over in this area, they're showing a lot of the grounds up close to the tubes. But over in this section, we have a lot of ground stuff going to ground here that we just connected with leads all over the place. But that's one where we have the diode going to the cathode and then going on to ground. Let's see here. Here's another one drawn a little differently. I'll have to zoom in on it. Here's a particular radio that we're using cathode bias for the triode. It's a 75 tube. We have a bypass condenser here, and that's all going to ground. The diode that we're not using goes directly to ground. In this case, they didn't connect it over here. They just decided to just go directly to ground. So this will be connected. If you had the radio there, it would be connected to the common grounds, whether it's right at the tube. It may be a wire going somewhere to a terminal strip that the mount is grounded on the terminal strip. But in any case, the diode goes to ground. That's just another way of showing it. We don't have all them wire lines drawn around here. Everything is showing directly to our grounds right at the very close to the points where they go. Here's a Philco right here where we're using the second diode. It's not going to ground. We have cathode going directly to ground, but here's our little capacitor that we put in. 110 picofarad cap. This is your standard detection circuit right here, diode, and then on this side after the 110 picofarad is our ABC circuit. The interesting thing on this Philco is how they develop some of this. Zoom out just a tad bit and still be able for you to see it. Is if you follow this down with T off here, well, we got 1 meg, and then that goes down to this divider circuit. This is coming off the center tap through a series of resistors and then to ground. What this does is develop various negative voltages that we need for biasing. This is used for 2 reasons dealing with that diode. One, it's developing the biasing voltage for the diode. And the second thing is when there's 0 signal coming through the radio, so that I have really nothing here to rectify and develop a negative, this supplies my steady state, no signal, negative voltage or bias voltage for my IF and my detector oscillator or mixer tube. When I do have a signal, it'll work in conjunction with the load drop across this resistor. This becomes my load resistor and gives me an AVC. Then is fed through a 1 meg coming over to my 0.05 cap here, microfarad cap. This makes my RC filter and for the audio, and we have our pure varying, depending on signal strength, varying negative voltage to the grids. Zoom in on this one, we'll show you a parallel diode circuit. In this radio here, the 2 diodes are connected together. We have a parallel diode circuit right here. So here's another example. Cathode to ground, the 2 diodes work in conjunction and feed out. In this case here, the volume control is definitely our load. The circuit comes down, goes through the volume control to ground, back to the cathode. So it's a 500K. This size absolutely is critical for the operation radio, that if it's replaced, that it be as close, if not exactly that value. But another situation, another way of connecting diodes. Alrighty. And then I told you that there are some tubes out there, the more newer radios, that have only one diode. The one H5GT, this is a battery operated radio, as well as it can be both battery and power AC. So it's AC DC radio. You got your AC there and your battery connectors there. But in any case, it only has one diode. That's it. Of course, this has filaments, in other words, directly heated cathodes. But there's only one diode in that tube. This is a much later radio. I think it's about all I've got on this. I didn't find too many. An example, Philco did a lot of putting resistor in here, but I hope that kind of clarifies things. But one of the primary things is those diode, that second diode can be hooked up in any number of ways, and the biggest thing is to always follow out your schematic and don't get confused. It's very important, imperative that you are able to follow out the schematic and see and locate your ground, see what's connected to ground, so you don't get or jump to conclusions about what's going on. And you also know where everything's connected, you know how everything is operating. You know, we have a cathode here, so the potential on that cathode, since it goes to ground, is going to be ground. So, but some schematics are very elaborate, whereas others are very easy. Everything is directly shown pretty much right near the tubes, and the circuits are going to ground. So that's a video that I didn't expect to be as long as this, but I just wanted to show how these different diodes can be connected and the various techniques and stuff. And there's other diode detectors. There's dual diodes, tubes like a 6H6, the 6AL5, to name a couple. There's 3 diodes in a triode tube, such as like the 6T8. And then of course single diodes with triodes, or single diodes with pentodes. They came in a variety of different things, and then also detection can be done by just a triode tube, and there's various methods of doing that. So anyway, I think that's about it on this. I can't think of anything else. So it's when you work on a radio, before you ever do anything to that radio, always familiarize yourself with the schematic. Look at the schematic, look at the radio or TV or whatever you're working on, and be able to pick out where everything is, be able to understand the flow of the signal through the radio, how the radio is working from that schematic, get a general idea. But be very familiar with the schematic and the radio before you ever do anything. So this helps both in replacement of parts and location of parts and the such, but also if you need to do any troubleshooting, it helps with that. So anyway, until next time, I want to thank you for watching and dropping by, and for your comments, and thank you to my new subscribers. Stick around. We do a little bit of everything as far as electronics goes, especially vintage. So I'll see you guys in the next video, and y'all have a good day.